Okay, so now they're going to give us a graph, and we have to come up with the equation for the rational function. So we're going to go by things that we know. If we look at this graph, one thing, we can see x-intercepts and we can see the y-intercept. So the y-intercept is at 0, -2, and we see x-intercepts at -2, 0, and 3, 0. Okay, so that's going to help us. We also see, it looks like an asymptote here, kind of, and it looks like an asymptote here. So we're just taking our best guess, on the asymptotes, and then it looks like the asymptote is also at the y-axis again. Okay, so let's put this together and see what we come up with. So we're going to say in the numerator, to get those x-intercepts, so this is where the numerator is going to come from, we're going to have factors of x plus 2 and x minus 3. In the denominator, to get these vertical asymptotes, I'm going to need an x plus 1 and an x minus 2. Now the question would be the multiplicity. So here the multiplicity needs to be odd. All right, so I'm going to leave it with multiplicity 1. And over here it needs to be even because you see they're both going down in the negative direction on both sides of that asymptote. Okay, so I need it to be at least a square. Now you could say, well, it could be a higher exponent, maybe, but we're going to go with the simplest one we can, okay? Because we don't really know what the graph is, so we'll go by that. The horizontal asymptote doesn't really tell us a lot. It tells us that the degree of the numerator has to be less than the degree of the denominator, and it is, so we're okay. The one thing that we don't know, though, is there could be some multiple here, some constant that we don't know about. So right now we have our equation our function looking like that. Could we find out what a is, what that multiple is? And we can because of the y-intercept. So we're going to use the y-intercept, and we're going to say if we evaluate this at 0, so f of 0, that would be a times 0 plus 2 times 0 minus 3, I'm writing this out again, over 0 plus 1 and 0 minus 2 squared. But we know that has to equal -2. So then I can solve for a. I'm going to come back up to that in a minute, but let's get some calculations here. So I'm going to have in the numerator -6a, right? And then in the denominator I'm going to have 4 equals -2. I'm going to erase this equal sign. Okay, so I can reduce that to -3/2 a. You could write it like that if you want to. And then get rid of the fraction by multiplying by the reciprocal on both sides. Something like that, maybe parentheses you want. Okay, and it looks like we're getting a then to be 4/3. So what we're going to do is we're going to go back up just a little bit, and we're going to put that in right here. So we're going to have the function f of x, and here's what we're going to do with that 4/3. We're going to put the 4 in the numerator, and then the 3 in the denominator. I'm not going to worry about multiplying out the factors, x plus 2 and x minus 3. You could multiply them out to make them polynomials in standard form, but it's not really necessary. Unless they ask you to. And then that's going to be then the function right there. So the math part, the calculating part, kind of came in when we had to find a, and we did that using the y-intercept. But other than that, we're using the x-intercepts to get the numerator factors and the the vertical asymptotes to get the factors of the denominator. Okay.